So now let's take a look at how we can build this example from scratch. So from the File menu, we'll choose New, Project, and Android Project. So this new Android project wizard pops up. The dialog box asks us a series of questions, including the name of the project, the target platform, and then some other stuff that ends up in the application that gets sent to the Android market. So, project name. So we're going to build this example from scratch. We're going to utilize the GPS receiver. We're working with Android here on this app dev course. We're focusing our attention this time on the Google API level 4. Basically, Android 1.6 is the open source. The Google API is a couple more additions, including some mapping libraries as well. So we see the reference to Android plus Google APIs. That's good. We see application name, AppDev, Android, GPS build example. And what we could also do is just to tack on to the end of this the word project, so that when we see this text pop up here and there, we can remember where it came from. So this is our project. This is our application. This is our package. And remember that this is our website address backwards, lowercase, so com.appdev. We have the top level domain, com. We have the second level domain, appdev. And then we'll tack on the project name or the application name after that. So let's highlight this, copy and paste it, and we'll remove the word application. We'll put package. So we know that package here correlates to the package label here. Application here correlates to application here. And also project here correlates to the label project here. So this is just a convention that we're using here in this course to make it obvious and simple where all this stuff comes from and where it's all going. So create an activity, yes, this is optional, and what it means is that we'd like to have a form that starts automatically by default. So we'll say activity. The min SDK version of 4, that's the API level. That correlates here to the Android platform, 1.6. That correlates to number 4 on the integer sequence. And we can skip the next window and just hit finish. So under the Project Explorer window, now we should see two separate projects. We have AppDev, Android, GPS, Build Example Project. So that's the one that we're going to work on from scratch. And if we open it up, one of the first things that I like to do is to always compile and build the template first before we find out that it's broken. We want to know that it works one step at a time. We want to fix each bug as soon as we find it. So under the source folder, we're looking for the .java file. We see that. That's good. Under the gen folder, we will see in a moment the r.java. Under resources, we could see the user interface, main.xml, and also the strings XML coming under the values. So every project is allowed to use its own run configuration. So we could say, create a new run configuration that binds this particular project to a specific emulator. So under Android application, we're going to create a new Android application configuration, and we'll call it AppDev Android run configuration. And we could put the build example on there so that we know that this is related to building the example from scratch. So what project are we going to bind this to? We're going to bind this to the AppDev Android GPS Build Example project. And what are we going to target that to? Well, there are a couple of different things that we can do. We've already set up this virtual device, and we can take a look at how to set those up in just a moment. But we have one that's already been set up for level 4 Google API, running this resolution on the screen, 640 by 360 by 72 inches. So this is a 16 by 9 rectangle in landscape mode. 72 DPI is going to match the monitor. Most of the phones are running a much higher density, like 160 or 240. But if we run that density on a monitor, it basically triples or quadruples the size, and it makes it actually go off the screen. So if we set up the deployment target selection mode to manual, we can actually answer this question after we start the app from the developer environment. So when we hit run, this little prompt will now come up every time we run the app, so that we can choose between either A, an emulator that's already running, or B, launch a new emulator, or C, if there's a USB port connected to a real phone, we can actually deploy this app to that real phone to debug right through the phone. So we have this emulator up. It already had an app running. It compiled and set our new app, and we see that here on the screen. So AppDev, Android, GPS, build example, application. Remember, this is the content that we typed in through the new project wizard. And then also AppDev, Android, GPS, build example, activity is another field that we typed into the wizard for the new project as well. So this is a good sign. We see the application template running here inside the emulator. There were no errors compiling the app. There were no problems sending it over into the phone. So let's go back over into Eclipse, and let's take a look at what we're going to do to build this example from scratch. Remember that here's the code that's already written. Here's our user interface, the strings, the bridge file, r.java, the user interface, and the manifest that's granting these permissions. And we can come back to them for reference purposes. So if we close all these windows and the console, we can start with a blank slate. And in the project window, let's start by looking at the user interface. So under main.xml, we have our preview window, and we have a bunch of things over here on the left, including some of the user interface components. So for example, under text fields, we could bring over a edit text, and we're also going to use a label as well, but we'll come back to that in just a moment. So if we flip over into the main.xml window, we can see that this is almost like building an HTML web page. We can drag and drop these objects, but basically all that's really doing is generating something that looks like HTML, but we'll call it the Android markup language because it is basically processed by the Android interpreter. So every attribute can be on its own line, and that makes it a little bit easier to read. So we have linear layout, that's the root node. Remember that if we were building an HTML document, that an HTML document contains a body tag. It's a child of HTML, and that's where we actually start doing stuff. Well, here in this example with the Android markup language, the linear layout serves the same purpose as the body tag here, because there's actually one level higher, there's one more node, and it's something like a frame layout or something like that, something else. But it's not a linear layout, but it is a layout object. So we have this linear layout, and we can see that it's set to vertical, which basically means that everything it contains will be arranged as if it was in an HTML table that had one column and many rows. And every object gets its own row. So here's the text view that gets its content from this hello variable from the file called strings.xml, and we can change this as a starting point for the application. So if we go back over into the folder called values and open up strings.xml, just another footnote to keep in mind, that there's a folder here called layout, and that contains the user interface main.xml, and that's the default, the primary. And when we flip the phone from landscape to portrait, basically it reshuffles the user interface twice using one file, one layout. But there's also a hidden file or a hidden expectation that if we add a folder called layout-landscape, LAND, that when the phone flips over to the landscape mode, it actually discards this particular UI and reopens the screen with the other UI. And the idea there is that all the objects have the same names, they're just in different places on this screen, and it basically allows us to optimize the user interface for a portrait view and a landscape view. But that's something that we can take a look at in just a moment. But for right now, let's start with strings.xml. So in strings.xml, we have a list of things. So we have a list of hello, app name, and we can add additional stuff as well. In fact, we'll do that. So hello itself, we can change that value. We'll just add a couple asterisks. just so that we know that this is the right file that we're working with. And if we save all the files here, this might be a good point to stop and test it out. So if we say launch this inside of our emulator, and we'll see the screen go blank for a moment, and there we go, 1, 2, 3 stars. So here's also the reference to the object that we added using the preview window, and we dragged and dropped that object. We can see some of the interesting characteristics about the formatting here. Why is it that the width of this object is stretching from the left over to the right? And the reason for this is that property for the width and the height. Remember that there's an option for fill parent, wrap content. And if we say fill parent, it's also it's a double-edged sword. It doesn't give us any room for a label to the left. So that's not what we actually need here. So if we find that edit text and we change the attributes here, we know that we want to create a new ID. So this is good, plus ID. We know that we want to call it something that reminds us that this is coming from the XML markup language. So let's call this, like we did earlier, ET1 XML. And when we create the same object handle in Java, we'll just by convention add _Java, just so that the first time around here and during development learning purposes, we know what this is pointing to. So this is pointing to the markup language ID. There's also an ID that we'll see in Java, and we'll call it something _Java. Now, as soon as we do this, we have this ID. We save the file. If we look over into the generated folder, under our package, r.java, under r.id. This is the object that currently references or points to the edit text. Now this value is outdated, it's out of sync. We can help the Eclipse environment out a little bit here. We'll just clean and rebuild. So now we can see the current value, so it's catching up with what we're typing, ET1 _XML, and we need another one. So we're going to have two edit text when we're done. And before we do that though, let's talk about this fill parent. We almost never need to use fill parent and should probably avoid using it whenever possible. So wrap content is much better because if we were building an HTML web page and we use something like a span or a div tag, the behavior is basically the same as this. So fill parent reminds me of the div tag in HTML. It expands out to the left and the right margin. Wrap content reminds me of the span tag in HTML because it only occupies the number of characters that it actually needs. So we have an edit text. We now have it set to wrap content. One thing that we can do is to put something in it. So we could say Android text is 0.123456.7, and let's make this the starting value, and then at runtime we can change this value when the application starts and also when the GPS receiver gets notified of a change. So if we hit save and run, that looks good. So 0 dot and then the 7 zeros that we typed in, we see the 3 stars. But the focal point here is the fact that the width of this edit text does not occupy the entire screen. It only occupies what it needs. And that's what we're going to use for both the longitude and also the latitude. So the next question is, how do we set up a label that sits to the left of this edit text? And the way that we can do that is by setting up a text view. So I can copy and paste just like I was building an HTML web page. The width now for this text view is going to say wrap parent because it's ultimately going to share the same row. Now it needs to be a row within a table, and the way that we do that is by using a tag called the table row. So here's the tag table row, and any tag that we don't know by memory, we can see it on the IntelliSense, but we can also see it under the graphical layout. If we just find something here that correlates to what we need, we can actually just drag and drop it over here. So we have a table row. That's a child of a table layout. So let's bring in a table layout as well. And if I put it at the bottom of the form, we could see that show up right here. So let's use this. We have 2 rows. 1, 2 is what we need. So let's take out 2 rows. And we'll grab the entire object and Control X, put it onto the clipboard. And actually these tags I can overwrite. I don't actually need them after all. So we have this table layout, and it contains row number 1 and row number 2. And if I was building an HTML table, I would have used the table tag, the TR for the row, and a TD for the column. But under the Android markup language, there actually is no need to use the TD tag. There's an assumption that every object within the row is its own TD. So to make this easier to read, let's set every attribute on its own line. And basically the table layout here, since it's going to contain both of the columns, yes, we can allow that to be a fill parent and take up the whole screen width. Now, one interesting point to note here is that although the template brought in an ID for this table layout, since we're not referencing this object programmatically from the Java side, if we were to delete it, everything would be okay because there's really no point in having a reference to it anyway. So table row, now set every attribute on its own line so that we can confirm that it's set correctly. We can read it easier. So we have this table row, and it will contain something, and what we'd like it to contain is the edit text and the text view that we just created. So Control X, put that into the clipboard, and then I'll paste it back in. So here we have a table layout that contains a table row, and the table row also doesn't have to have an ID, because in this example we're not going to reference it programmatically. The table row contains 2 columns, and we don't have to use TD or a table data or any kind of HTML carryover on this particular step. So the text view is the first column, and basically it's a label that we would see under VB.net, and we can see that the width and the height are set correctly. Wrap content, we always use that by default unless we need to actually expand it to the full width or the full height. The content for this text view, it's going to be a label, and let's just start off by not referencing the strings XML, but just put in like lon for longitude, and we'll come back and make it uppercase next time around. So here's our label. It's hard-coded as LON, and we'll come back around and switch it over to a pointer to the strings XML file. The edit text now. So the edit text is basically containing content that changes, and there's an interesting behavior about the text view. So for example, since text view is basically going to display content that the user doesn't update, typically we could have also placed in VB.net, for example, a label here. But it just so happens that under Android, the text view is an object that doesn't want to refresh its content very often. In fact, we can set it once here in the markup, and we can change it once under Android. But depending on what version of the platform that we're using, it doesn't want to change a third time. It basically isn't designed to destroy the content of its string, like its string builder or whatever that's inside of it. It wants us to actually destroy the text view, create a new one, populate it, and bring it back into the table row. So that's what the expectation is of the environment on the text view. It's not behaving the same way that Microsoft manages their label object. So since we're going to update and refresh the content of the longitude over and over and over again, we're actually going to use an edit text, and we can also set this to be read-only so the user can't type it in if we wanted to do that. So we have this edit text. It does need to have an ID, and the reason for that is that on the Java side we're going to reference a handle here, and we're going to do a set text to update this 0 to the actual value coming from the receiver. So that's it. We've got the first row, and before we make the content here for the second row, let's stop, let's pause, let's save all this work, launch it in the browser, and if there's an error, we want to find it now instead of building up a bunch of stuff and then finding out later we have an error. Okay, so what is this? It says that there's a problem. The tags don't match up correctly. So here's an edit text, and the closing tag is missing to make that a unary tag. We could have also done something like this that would have done the same thing. We could have a closing tag that says closing tag edit text, but we don't want to do that. We actually just want to close it like this. So let's try it again. And we'll track down, we don't need this right now. So we have this table row, we see an error message here. Table layout, table row. And here it is. Okay, so this edit text is the closing tag that was the ending tag here, and since we're going to close it here, we don't need it. So this is causing the tree to get out of balance. Okay, so we'll save this. Try it again. That looks better. So here we go. We have LON, L-O-N, stacked as a label next to this edit text. We're using the markup language under Android, and this looks good. So let's change this LON constant to point to the lookup file for strings. So we could change this to say something like @string/ hello1, and remember that this is the same format that also the template uses. So @string/ hello is what we're seeing right here under strings XML, and this is like a config file. And if we added another entry in this config file, we can actually put our label here. So longitude colon, and since we're here, we can add latitude, even though we're not using it. We'll have it ready. We'll give this a name, hello2, latitude. So how do we reference that? Let's save this, double check this. We reference it through @string/ hello. And if that works, then what we can do is come back and just copy and paste this whole row and make a couple of tweaks to it and duplicate the effort. So back to the emulator. There we go. Longitude, all uppercase, coming from strings XML. So why don't we just take this whole row and tweak it. So we have a table row that contains a table view. The label is going to come from a different strings XML called hello2, and we'll change the name here for the object. We'll call it ET2, edit text 2 in XML. Okay, so let's stop again. We'll one step at a time, inch by inch, we'll work through the code. So we have longitude, we have latitude, we have edit text 1, edit text 2. So that looks really good. So one of the next steps that we'll take a look at is the Java side, but before we get there, let's double check one thing. If we look at the generated code, and if we look under r dot, here it is, r.id dot, we see ET1, ET2, that's perfect. That means that the bridge has been set up between the markup language side of main XML and also the Java side for referencing that same object here from the code that we write in Java. So if we work our way back into the Project Explorer window and look at this file under the SRC folder, remember that the Java side is under SRC, all the markup language is under RES, resources, and we're looking for this .java file. So here we see the reference to our activity. We could put this on a separate line here, so we have a class that extends activity, and in just a moment also we're going to implement the interface for a GPS listener. Currently, we're importing android.app.activity, android.os.bundle. Those are standard import statements. And the onCreate function is telling the operating system to go over and look at the markup language files called, in this case, main.xml, and make that the opening screen. So we know that there are edit text objects that are in the form that we want to update, and we may or may not want to be able to update them from many different functions. So one way to manage that question is to create the edit text object here, and we'll call it underscore Java. So this edit text object is undefined currently, so we're going to import the library that defines what an edit text is, and that's why we have edit text.widget.android now that appears here under the import statement. And we want to be able to point to it and change its value. So what we're going to do is say that the edit text one, ET1, is equal to something. And what we want to do is to rely on the find view by ID function to get the pointer to that little memory space. And the way that we're going to do this, we'll say paren, so typecast to an edit text object. This current context, this dot find view by ID, r dot ID dot, and here we go. So this is the r.java file reference. Next, what we could do is to set the value of it temporarily. So we could say et1 java dot set text, and we could put longitude temporarily into that box before we put a number there. So let's stop here in the coding. We'll save this work. Let's launch this in the emulator and see what happens. That looks good. So the value for this edit text is programmatically being updated via the onCreate, and we see the value 0 that's still sitting in the latitude. So the second step would be to set up a handle to latitude like we just set up the handle for the longitude. So the way we do that, we'll set up another object to point at that. And copy paste the logic, and we'll tweak it a little bit. And that looks like it might work. That looks good. So longitude, latitude, it's finding the right edit text box. Now what we want is to see a number in there, and we also want to be able to fire through the emulator the values for the GPS receiver. So the next question then becomes, if we know how to update the content of an edit text, and we know that the edit text expects a string, how do we convert a GPS value from a floating point value, a decimal value, into a string? And how do we get the actual floating point value from the location manager as a location object? So what we can do is to set up a reference to the location manager, call it LM1 in this example, and we'll set it equal to something. But before we do that, we're going to import the reference to what is the definition of a location manager, and we're going to set it equal to something. So we're going to typecast the return value that comes back from our system request. The system request is going to be location manager, and then get a system service, and the name of the service. So we kind of have to memorize this piece, but we can look up the property here for location underscore service. So now we get this yellow squiggly. The yellow squiggly says that there's nothing technically wrong, but it seems like we're wasting time and space not utilizing an object that we create. So the next line will use this. So lm1 dot, we want to request updates, and this becomes very interesting. The parameters that are passed in here. First of all, the provider. In our example, we want to use the GPS receivers. So there are a couple of different ways to look at this. We could use network GPS, or we can call a function call that says what's the best available, because what if the GPS receiver is actually disabled by the user under the settings window? So we might want to ask that question, but we're not going to ask that question here. We're just going to say we want the GPS provider. It's a string, GPS. The minimum amount of time, so 1 millisecond. We could say 1,000 milliseconds. We could say 1,000 times 60 and have it be 1 minute. The minimum distance, 1 meter. And then there's a reference to what object is capable of responding to this event notification. So we'll start with the reference to, so request the provider. Basically we could put GPS, or we could put that reference to the constant like we did in the previous example. The minimum time, we could say 1,000 milliseconds times 60. That would be once every minute, or we could just leave it as 1,000. That would be once per second. Or we could just put 1. It just basically says as soon as we get an update, that will reflect that immediately. 1 meter, the minimum distance, and the listener. So the listener is basically a class. In this example, we'll use the current class. So request location updates is expecting a reference to an object that implements the location listener interface, and we're saying that this class does. If we look at this class, there is no actual reference to declaring the implementation of that interface. So we could say it implements the location listener. Now this generates another red squiggly. What is the definition of a location listener? So we bring that in. Here's the location listener.location.android, which generates another red squiggly. So it's almost like playing that gopher game where you hit one gopher head and another one pops up. But what this next question says is that if you actually intend to implement the standards, the requirements of a location listener interface, then you better also have the functions that do that. So if we hover the mouse over the red squiggly, we could say add all the functions that we don't memorize what it needs, but here they are. So there's a function called onLocationChange. There's another function called the provider's disabled. So for example, we were listening to the GPS receiver for 100 miles and then the user turns off the GPS receiver to save battery. We would want to know that. We want to know if it got turned back on. We want to know if there's any status change to the receiver, even though it's not powered off or on. Maybe something changed. So basically, an onLocationChange, we're getting this reference to this location. We'll call it L1. So L1 is the location that contains the stuff that we need. We could set content into the log file to prove that. We'll bring in a definition of a log file. Log util Android. So we could say something like this: L1 dot get the longitude. Now this is a number, but the log file and also the edit text wants to see a string. So the string object has a value of converter that takes the value of a thing, and that looks better. And we could tweak this slightly and say get the latitude as well as the altitude. And while we're here, an interesting footnote about altitude on most Android phones is that the accuracy is way off, and you could do a little research on the blogs about that, but never fly an aircraft expecting to read an Android phone because it could be off by 7,000 feet reading could actually be 30,000 feet altitude. The factor is 50% off frequently. So it goes up and it goes down, the altitude signal. If you read the blogs about why it's not as accurate as, say, a Garmin hiking device or a Garmin aircraft device, that's a long story. So get altitude, get latitude, get longitude. And we're missing one balancing parentheses. So onLocationChange will get fired whenever there's a update to the GPS receiver, and we can test that very easily. What we can do is we'll save the file here. We'll launch this back into the emulator. And we broke it. Okay, so why did we break this application? Why did it crash? We're referencing the GPS without permission, and we could trace that down in the logcat. I'm jumping to the conclusion that under the settings for the log file, that there's some red stuff. Here's all this red stuff. And if we trace it back, unable to do a thing, security exception, access find location permission. So we can fix that really easily. If we go back to the app that's already built, if we borrow the syntax for the config file of Android manifest, this may or may not be something that we want to memorize, but we can copy and paste it from project to project very easily. So copy, close, go back to the manifest for the new project, and set these project properties. We'll jump right into the XML. We know right where this goes. So we have a permission request, uses permission. Access find location is basically what the GPS receiver is. The course location is what the network location is going to come from. So we'll save that. Let's try it one more time. Make sure that worked correctly here. Stepping back for here just a second here, we're going to say project clean. And we're not getting any red messages now. That looks hopefully good. But we're still getting a red message here. So there's a problem that we need to debug. Okay, so when we look at this example, one of the differences between the manifest here is that we reference the permission for the GPS. But if we go back, let's take a look also at the code for the manifest on the other original project that we did the demo for. And there's actually two references. So the reference to the network and the reference to the GPS. So the location manager may or may not want to try to check the status of both. So let's grant permissions to both. And we'll say paste. So let's paste it differently here. Paste it right here. So let's try this now. GPS permissions, network permissions, save, go. And that looks much better. Now, how do we send content over to the application? Remember that there's a window for the emulator, location controls, that allows us to send values. We can put in a different value here. We'll put 124 and hit send. Now, currently, we're not updating the edit text yet, but we are sending content to the log. So if we open up the log, jump to the very bottom, we do see something coming out. Longitude 124, latitude 40, and altitude. So this is interesting. We actually have a mirror of that too, so we have two sets of data going out right there. But this is good because it basically says that it's listening to the emulator controller. Now, if we go back, let's go back into the code under the Java. And this value here we could actually change to something more descriptive. So we have location change events, and one thing also that's happening is that the GPS updates are going to all applications within the Android OS. So if we get two sets of data we might want to clarify this is coming from, we'll call it app 2. From the build example, I'll add the PE just so we know this is from building the example. So we'll hit save, go. We're looking at the current satellite value for the, well, just a moment ago. So we'll send content, we'll say 125. And we don't see anything yet. We're going to add that code in just a moment. But under the log, here we go. So we see on location change from our app to build example coming out. But remember that there are other applications also listening to the GPS, and that's the demo app that is also running on the same phone in the background, and it's sending out log file entries as well. So that's perfect. Now what we can do is to add a couple lines of code that say, in addition to sending this out into the log file, we also want to do something else. We want to say on the edit text, the Java reference, we want to set the text value to something. Now remember that this is coming from the user interface. This is coming from the edit text on the screen. It's called ET1XML as a markup language object. We're bridging that gap under the generated code with this r.java file and bringing it over into the context of, let's close that, that's the demo and this is our code here. So the r.java file is bridging the gap, and if we go over into our code, this is the actual reference from the Java file. So set the text to something, and we're going to basically do the same thing earlier, convert a string value and we'll tweak that. Actually, we don't have altitude displaying, just longitude and latitude. So we'll tweak this. And that should look good as well. So now we have a chance to see the updates going to the log file and also into the user interface. We'll save that. Let's hit go. Wait just a moment here. Now by default, the value of the onCreate code setting the longitude latitude is what we're correctly displaying, and we'll wait until the environment here actually sends new values. So here's our Java Eclipse developer environment. Here's the numbers we're sending. Change this to a 126. Hit send, and bingo. We'll change the value for latitude just to double check all things, and bingo. So that looks perfect. So what we've just done is to write an application that utilizes the GPS receiver. It gets an update when the value of the phone changes by 1 meter, and it will change within a millisecond of an update. And basically what it says is that we don't want to be notified any sooner than 1 millisecond. We might set it to 1,000 milliseconds, for example. It's calling a function inside that class. We set up the this reference to this current class that we implemented the location listener on. So that wraps up our first example of utilizing the GPS receiver.